Hello all, welcome back to Free Response Review. We are on the 7th video here, and we are just going to be covering kind of some random topics. We're only going to do one question today in this video, and that's because I want you to spend some time studying and getting ready for your test. But specifically, we're going to be looking at a question that has a piecewise function, talking about concepts like continuity, derivative rules, average value. So that's what we're going to hit tonight, and then we'll repeat some of that next class, as well as touch on a few other random topics. All right, let's get started. So we're taking a look at 2011 number 6. This is a no calculator question. There are 3 parts to this question, an A and a B and a C. And so we're going to go ahead and get started on part A. Let f be a function defined by f of x equals the piecewise function 1 minus 2 sine x for when x is less than or equal to 0, and e to the negative 4x for when x is greater than 0. Okay, part A just asks us to show that it is continuous at x equals 0. All right, so remember, if we are proving something is continuous, I want you to pause the video right now and write down the rule or the proof for something being continuous. And I'll do the same, and we'll make sure that we agree. Okay, so hopefully you've written down something that looks a little bit like this. The limit as x approaches 0 from the left of the function, does that equal the limit as x approaches 0 from the right of the function? Does that equal the function at 0? Okay, so all 3 of these conditions need to be met in order for this function to be continuous. All right, so now I'm just going to go ahead and do each of these tests. All right, so the limit as x approaches 0 from the left of the function. Well, which of these functions is coming from the left? I would definitely say this one here. And so I'm going to go ahead and say 1 minus 2 sine, and I'm going to go ahead and put in the 0. So sine of 0 is, of course, 0. So 2 times 0 is 0, so it's just 1. Okay? Does that equal the limit as x approaches 0 from the right? So that's obviously the other part of the piecewise function. That's the e to the negative 4 times 0. And of course, e to the 0 is just going to give me back a 1. All right, and lastly, f of 0. So the idea here is that one of these has an equal to 0 and one does not. And obviously, this one is less than or equal to 0, so I'd be looking at the 1 minus 2 sine of 0, which of course we already figured out is 1. And so yes, it is true that the limit from the left is equal to the limit from right, which is equal to f at that value. And so therefore, f is continuous. Letter B asks us, for x not equal to 0, express f prime of x as a piecewise defined function. Find the value of x for which f prime of x is equal to negative 3. Okay, so start off by just taking the derivative. And when you take the derivative of a piecewise function, you just take the derivative of each of its branches. And then this is important. They're already telling us that x does not equal 0. And so that means that when I make my piecewise function, I do not include x equaling 0 for the derivative. All right, so I'm just going to go ahead and say f prime of x is equal to. All right, I want you to pause the video, take the derivative of each of these pieces, and write them in your bracket here. And then come back to me and see if we agree. Okay, so hopefully you agree with me that the derivative of 1 minus 2 sine x is simply negative 2 cosine of x. And it's just for x is less than 0 because of what they said over here, x cannot equal 0. And then the derivative of e to the negative 4x is e to the u, so e to the negative 4x times the derivative of the exponent, so negative 4 came out in front. And that's for x is greater than 0. Okay, so that was the first one, and that was worth actually 2 points. So that's awesome, okay, that you are able to come up with 2 points just for finding those 2, in my opinion, pretty simple derivatives. All right, the third point is finding the value of x for which f prime of x is equal to negative 3. Well, basically, they're not giving you the x value, they're giving you the output. And they're saying for which of these is it possible, first of all, for the derivative to equal negative 3, and then find the value of x for which that happens at. All right, so if I take the first branch of my piecewise function, negative 2 cosine x, can that ever equal negative 3? Well, I want you to think of negative 2 cos x, okay? Hopefully you're remembering a little bit about trig graphing, and you remember that this number in front is our amplitude, and that represents the min and the max, or the height above the midline, which since you're not adding or subtracting anything here, your midline is 0. So this is basically a graph, okay, our cosine graph that has a height of 2 above the midline, and because it's negative, it actually starts down here. So it would look like this, okay, and this would be positive 2, and this would be negative 2. And so this graph would obviously never get to a y value of negative 3. Therefore, this will never happen. And so now we move on to the second branch of our piecewise function, negative 4e to the negative 4x is equal to negative 3. And now we have to solve that one. All right, so if I have an e function and I want to solve it, first thing I'm going to do is go ahead and isolate my e function. So e to the negative 4x is equal to 3/4. Okay, next thing I want to do is take the natural log of both sides to get rid of that e. So when I take the natural log of the left-hand side, natural log of e to the negative 4x equals natural log of 3/4. The natural log of e goes away, and I just get negative 4x equals natural log of 3/4. And the last thing to do is divide that by negative 4, or you could write that as negative 1/4 times natural log of 3/4. So I squeeze that in there. All right, so that is my answer for that second part of the question. And that is only worth 1 point. Okay, so this up here was worth 2 points, and this down here was worth 1 point. All right, part A was worth 2 points as well, and it just says 2 points for the complete analysis. So I would say finding the limits from the left, from the right, and also showing that that's equal to the function at 0, and then making the conclusion that it is continuous. All right, let's move on to part C. Okay, this last question is definitely a big involved question, so stick with me as we work through this. I want to make sure that you are catching all the points of what it is that we're talking about here. Okay, so it's asking us for the average value of f on the interval negative 1 to 1. All right, so as we start off here, let's try to right away remember the formula for average value of f. So average value is 1 over b minus a times the integral from a to b of that function that you're trying to find the average of. So of f of x dx. All right, so, and obviously our a and our b here are negative 1 and 1. So this would be 1 over 1 minus negative 1 would be 2 times the integral from negative 1 to 1 of f of x dx. All right, now when you have a piecewise function, this piece of it, okay, the integral from negative 1 to 1 has to be split according to your breaking point. So we have a breaking point of 0. So basically what I'm doing right now is I have to write this as 1/2, and then I'm going to split up my integral based upon its two pieces of the piecewise function. So the first piece is for x less than or equal to 0. So that would be from negative 1 to 0. So I'm going to say the integral from negative 1 to 0 of an f of x from negative 1 to 0 would be the 1 minus 2 sine x dx. Plus, now I have to pick up at 0 and go up until 1, and that would be my second part of the piecewise function. So the integral from 0 to 1 of e to the negative 4x dx. All right, and then once I find both of those integrals, then at the end I'm going to take half of that whole answer. So this is a big question. This ends up being a 4-point question, okay? And so what I'd actually like you to do right now is pause the video and work through finding the integral of each of these pieces. All right, so this one right here should be very straightforward. The integral of 1 minus the integral of 2 sine x. Okay, so that one should be really straightforward, and you don't have to use any u substitution, really straightforward. Over here, the integral from 0 to 1 of e to the negative 4x, Not quite as straightforward, okay? We're going to have to use an u substitution on that angle. If you're doing the integral of e to the something other than x, you have to use u substitution. So pause your video, do the integral of each of these pieces, and then come back to me and see if we agree. Okay, so I kind of broke it up in some different colors, hoping to kind of help us through this. All right, so first of all, the first integral, the one with from -1 to 0, I did in blue here. And like I said, this one was ready just to go right ahead. So the integral of 1 is x, the integral of -2 sine x. Well, I wrote down -2, but then the integral of sine is negative cos. So I went back and changed this to a plus sign and then cos x from -1 to 0. And I just rewrote that again because this one over here, the second integral, the one from 0 to 1, that definitely took a couple steps. So like I said, I had to use u substitution, put that off to the side. Du is -4 dx, -1/4 du is dx. Okay, now I'm ready to take this stuff and put it back over here. Integral from, right away I changed my bound so I don't forget. Okay, how do I do that? Well, I plug in this 0 in for x here. So u equals -4 times 0, which is 0. I plug in the 1 for x. So u equals -4 times 1, which is -4. E to the u, because -4x is now u, instead of dx, I'm replacing that with -1/4 du. Okay? Then I just took the integral of this piece. My constant, -1/4, came out. The integral of e to the u is e to the u, and that's now from 0 to -4. I'm keeping it in terms of u. I do not replace it back with -4x because I changed my bounds. It's easier this way. Keep it in terms of u. Okay, so now you have all of that work, okay? So now I am ready to go ahead and start doing the computation of all of this. All right, so I'm just going to kind of pull this up here. All right, to here. All right, and I'm ready to start doing the computation. So this 1/2 is still out here. All right, so I'm going to plug in my upper bound minus my lower bound. So I will have, for the blue one here, I'm going to have 0 plus 2 cos 0 minus, lower bound would be -1 plus 2 cos -1. Okay, and then plus, so this was all the first one. Maybe I need another set of parentheses wrapping that whole thing. Plus, and now I'm going to go ahead and plug in my upper and lower bound here. So this is -1/4, -1/4 e to the -4 minus -1/4. So actually that's going to become plus 1/4 e to the 0. Okay, so I'm going to continue on. Next line, 1/2. All right, so let's figure this out. 0 plus 2 cos 0. Well, cosine of 0 I know is 1. So 2 times 1 is 2, plus 0 is just simply 2. Okay, minus -1 would turn into plus 1. And then 2 times cos of -1. Well, I don't know the cosine of -1. This is like -1 radians, remember. We're not in degrees, okay? So, and I don't know the cosine of -1. That's not something from my exact value chart. That's not something I'm supposed to know by heart. So I'm actually going to leave this as -2 cosine of -1. All right? Now, I have plus -1/4 e to the -4. And then plus e to the 0 is simply 1 times 1/4 is just 1/4. Okay, so at this point, I want to go ahead and combine all of my like terms that I have, which really are just my constants here. So I'm going to change these in terms of 4. So this here would be, instead of 2, I'd have 8/4. Here I'd have 4/4. So 8/4 plus 4/4 would be 12/4 plus 1/4 would be 13/4. So I have 1/2 times 13/4 minus 2 cosine of -1. I'm going to change that to minus 1/4 e to the -4. Okay, last step would be just to go ahead and distribute that 1/2 through. So my last step here is 13/8 minus half of 2 is just 1, so I'm not even going to put the 1 down. Cosine of negative 1 minus half of a fourth would be 1/8 e to the negative 4. And that ugly thing is my answer for part C. And like I said, that was a 4-point question. As far as where the points come from, you are going to get a point way back up here. Sorry. Just for going ahead. Oh, gosh. Sorry, you're probably dizzy now. Just for going ahead and recognizing that the integral from negative 1 to 1 of f of x dx has to be split into the integral from negative 1 to 0 of 1 minus 2 sine x dx plus the integral from 0 to 1 of e to the negative 4x dx. So there is a point just for that. Then you get 2 points for correctly doing the antiderivatives. So a point for doing the antiderivative here and a point for doing the antiderivative here, obviously using that u substitution piece over here. Okay, and then your last point is for the answer. So after you've done your antiderivatives and plugged in your upper and lower bounds and combined all your like terms, and we finally end up with this ugly answer here, okay, that's your last point. So I'm not exactly sure where, all that comes in, but that is encouraging that it seems to me, again, I'm not an expert, but it seems to me that up to this point right here, up to doing the antiderivatives, which this is technically the antiderivative, you are earning 3 points. Then putting your bounds in and getting your final answer seems to be the last point. That seems a little extreme for me, but that's based upon what they are saying. That's how I'm getting that points. Okay, so I know that was a long one. As far as getting through just that one question. So thanks a lot for sticking with me. I'd encourage you to use the extra time you have this evening or tomorrow or whatever to make sure that you're studying and practice old test problems and old exam problems, things like that, and just getting ready for your test next class. All right, see you then. Have a great night.